Hi Arnab, how are you?
Yes, I am fine.
All good?
Yes,
Okay, so you have screen or you'll write on board?
I will be right both.
Okay, okay.
You chalk
So it
and
should be visible while you write. Okay.
not visible.
Now it, oh, board is very small. Okay,
Yes,
it's fine.
yes.
Okay, okay. Yeah. So tell us about yourself first of all.
I am Anna Bhattacharya. I uh, I have pursued statistics honors from RTUS. I am living in Kolkata.
You are not
Is
audible.
sound is heard or my sound is correct or
No, he is not
sound,
audible.
sound is not correct. Now it's correct.
Better. Yeah, tell me.
I'm Anna Bhattacharya. I have done statistics honors from RTUS. Results are out last
Okay, so what topic in mathematics are you interested?
linear algebra.
Good. Good. What is okay? You know what about what vector space is?
Yes.
Okay, so can you give me an example of infinite dimensional vector space?
What do you say? Infinite? What?
Infinite dimensional vector space. Can you give me an example of this
Again say infinite?
infinite dimensional vector space?
Infinite dimension vector space. It can be natural number. Dimensional vector space. No, no, no. It's polynomial function.
Yeah,
Well,
feel free. Don't worry. Feel free. Take your time. Think a lot. Then answer.
infinite dimension vector space can be polynomial whose basis is 1 x 6 squared.
Yeah, you are right. You are right. But what is a vector space?
Vector space, I have to define.
Uh, Right on board.
Vector space is a non-empty set. Vector space is a non-empty set uh, where if AB is element is belongs to A, then A plus B belongs to E, and alpha
Oh,
A.
do not write the definition of a vector space. I just told you to write the example of infinite dimensional vector space. Just write that only.
Oh,
And bring
is
your mic closer to your mouth.
oh, it's is Ivanix system plus is a polynomials.
Is this a definition? Is this a polynomial?
Uh, at the degree it's degree n plus degree it's degree.
What is A not A1, A2, AN?
These are constants.
So AN can be zero. It's true or
In
false?
yes, in can be zero.
But then it is not the degree of n. You just said na
Yes.
degree n. But then it is not degree of n.
In in is the integer. Integer. It belongs to integer. Integer and natural. It's natural.
No, I
It can
told you for an, the coefficient of x to the power n, an.
yes. Yes, n can be zero. It
No,
is a I am not saying the exact polynomial n. It's for
exactly.
it
Very good, very
total
good.
polynomials.
Don't say it is of degree n.
I
Okay.
don't. I am not saying it's degree. Yes, I don't say
Yeah,
it is not
yeah.
vector space. Degree.
Hmm. Okay.
Exactly creates one.
Okay, you know what idempotent matrices is?
Yes. I think putting matrix is S square equals to A. S square equals
Okay, is it diagonalizable? Idempotent matrices.
to no.
Okay,
It's
so identity matrix is diagonalizable or not?
identity matrix diagonal. Then
And
other identity matrix. Yes,
is
yes.
it okay? Is it idempotent?
Uh, oh, yes, yes. This identity type.
And we said idempotent matrices are not diagonalizable.
Yes. Oh yeah, yes. Identity matrix is example. But I don't think other metrics are diagonal. I'm not sure.
Okay. Think about it. Okay. What is basis?
This is a group of vectors, that is linearly independent.
Write it on board. Actually, you are not clearly audible. That's why I mean not
Then
able
like
to hear you
x1.
properly.
Can you see? Can you see? Uh, x1 is to total xn is called a basis. Called basis. And if linear combination of this a1 x1 plus a n xn equals to 0 for all ai's equals to 0. Right? It's nearly independent and linear span of this is linear span if the first this is first the second is every vector of this vector space can be written as a linear combination of this is a linear combination and every vector uh, it can be written as a linear combination of these vectors. So this linear span will and it's linear. This is for all
No, you are not precisely saying.
this
Okay,
one.
so can you construct an example of a set in which there are two independent elements in R cube?
Two independent um, two independent vector. This is a vector. Circuit graph. Here E1 and E2 two independent.
There you
E1
go. Write it in
is
the set form, na? Why you leave the brackets? I don't know.
oh
Why you are leaving the brackets?
hmm?
Put the brackets for
Yes.
a set notation. Why you are leaving like even it were like some randomly freely moving in a space? Put the brackets.
Yes. Next. Why I am putting brackets? That is a question.
Okay, I told you to construct a set. So for the notation of set, it is defined like that. Bracket E1, comma E2, then bracket close. Okay,
Oh, this
not this one, the middle one bracket,
this
not this
this
bracket, not
not really.
okay. In the last I will tell you. Okay,
This
so okay. Shall I move to the next question?
this
Once. What are the eigenvalues of nilpotent matrix?
zero. All eigenvalues are zero.
And what is index
What
of
is
nilpotent matrix? What is
index?
index of a nilpotent matrix?
Index
Yeah.
is e to the power p equals to zero. This nilpotent matrix is a integer. Integer. Then p is called index of that nilpotent matrix.
No other condition. Okay, find the index of a zero matrix then.
Geometrics.
Zero matrix, zero matrix. Find the index of zero matrix of 3 cross 3 order.
Geometrics. Geometrics. For geometrics, is we can be anything. One, two,
Can be anything.
three. Yes. So,
Don't you think index should be unique?
I got
Okay. Okay, what about linear transform? Yesterday?
uh, linear transformation.
Yes or no?
Yes.
Define kernel. What is kernel of a linear transform?
Kernel of canonical transformation is it is a linear transformation. Then tx equals to 0. Uh, the set for which p maps to 0 is a conic.
Now write it properly. Not the definition, but write it properly. Is it set px equals to 0? What is this? It's an equation, not a set.
Don't feel like exact notation. Yes,
Okay, okay, think about it. One last question from my side is, do you know diagonalizability of a matrix?
yes.
Yes, okay. And you know nilpotent also. So can you give me an example of a nilpotent matrix which is also a diagonalizable?
That is what we are. Yes.
Are you thinking or shall we move to the
Yes,
next?
yes, I'm thinking. Uh,
Okay.
I think it's null. So, yes.
Yeah, good. Correct. It is zero matrix only. Okay. Okay. Yeah, fine. Thank you. Thank you, Arnab. Yeah, Raghav, go ahead.
Yes,
Thank you, sir.
yes.
Uh, Okay, Arnab, I'll be asking the probability part.
Let's take
Uh, okay. So say you have a coin which is biased. So and you are said that you have to conduct an unbiased experiment with it. How would you proceed?
a point which is
A coin.
unbiased.
The coin is biased,
Biased.
and you have to conduct an unbiased experiment with it.
I have to convert in unbiased.
Right.
Unbiased part.
Unbiased experiment with it.
Yes. Yes. If one is biased, then probability x is not equals to probability. But probability of HT equals to probability of KH, right? Then we that means we toss 2 points. Then their sample space would be this HT, KH, and K. And from this, we experience stands so that if we got HS, HS or PT will increase. If we got HT, then we choose one. If we got PH, then we choose one. Because these two pointers in oh sorry, this is not same.
Yes, that is correct. Now say you have an unbiased coin that lands on head with probability P.
Unbiased point and
No,
probability
biased coin. Biased coin.
by
Probability of head is P, and you flipped it 10 times. Okay.
it is
Now, given that you get a total of 6 heads, what is the
six
conditional probability that the first three outcomes are HTT? So the first three outcomes are head, tail, and tail.
past three outcomes, but HTT. Yes,
HTT. Right.
HTT given 6 heads.
Given 6 heads. Right.
Given 6 hits. This is n times.
10, 10,
N times and each hits there.
10, 1, 0, 10.
First, so start with HTTP. So probability of 6 hits. Probability of 6 hits. Starting with HTTP. This is 6 hits. Probability of 6 hits n times. N times and point of it is P. It's binomial NP. Sorry, so there are 6. This is number of this. Plus 6. N minus 6.
Uh,
This one.
Arnab,
Uh,
the total number of tosses is 10. 10, 1, 0, 10. It's not n.
oh, N equals to 10.
Yeah, it's 10.
Okay. Okay. It will say it's complete. Start with HTTP and 6. HTTP is going to HTTP is going to accept this 2 raise 7 classes with 5 hits. Raise 7 classes. 3 classes from 7 classes with 5 hits. 7 classes with uh, uh, with 7 keys. So 7 keys raise 5 hits. 7 keys 5. 7 keys 5. 5 hits. 5 and means 12. Okay. And
Okay, Arnab, that's correct. You can stop here.
uh,
Uh, Say you have a line of unit length.
minor
of unit length, length 1.
Yes. Yes.
2 points are chosen at random on this line. You need to calculate the probability that, so the three line segments are formed, right? So you need to calculate the probability that the length of each of the line segment is greater than 1 by 4.
Each of line segment is greater than 1. So its length is x, OA, length is x. Any length is y. And this length will be 1 minus x minus 1. This is length. Right? We see each length will probability greater than 1. So, and x and y both follows uniform 0 can take any length less than 1. And both follows 0. Now, each length is greater than 1 by 4. Y is greater than 1 by 4. And 1 minus x minus 4 is greater than 1 by 4. X plus y less than 3 by 4. X plus y less than 3 by 4. So, just x plus y less than x plus 1 by 4 is this is there is for triangle. Triangle. This is x plus y equals to 3 by 4. And under this area, also required is total area is 1 and area of this is greater than 1 is 1. Y equals to 1 by 4 9 and so x equals to half. Half 1 by 4. Half 1 by 4. 1 by 2. So the rate will be half half minus 1 is so sides will be 1 by 4. So this area, so half into 1 by 4 square, 1 by 32. Like each will be 1 by 4. Yes. Have I did it?
Sorry, you're not audible.
Have I done it?
What's the answer? It's not visible. What have you written at the bottom?
1 by 32.
1 by 32. Recheck once.
Each.
Recheck. I don't think it's 1 by 32. It's a little off. Check your solution once again.
It's greater than 1 by 4 or less than 1 by 4? Each
Less than 1 by 4.
Oh, I did it for greater than 1 by 4.
No, sorry. No, it's greater than 1 by 4.
Greater than 1 by 4, right?
No, it's greater than 1 by 4. Greater than 1 by 4. Your answer was correct, but you are missing 1 point.
Don't.
Arnav, am I audible?
Yes, I am. You are audible.
It's greater than 1 by 4. It's greater than 1 by 4.
Huh?
Yeah, it's greater than 1 by 4.
It's greater than or less than?
Yeah.
It's less than?
No, greater than 1 by 4. All the three line segments have to be greater than 1 by 4.
The three line segments are greater to 1. Right. So it's greater than 1 by 4. 1 minus 6 minus y is greater than 1 by 4. So, 0 plus y. So, x plus y is greater than 1 by 4.
what you did was correct. Okay. Now you got the answer is 1 by 32. You got 1 by 32 now. See.
Or
So
the
the
answer is
an
not wrong.
yeah, the answer is 1 by 16. Think why.
So it should be. Oh, I got it. I got it. Sorry, I got it. Actually, the sample space should be not this part. Sample space should be this part. Right? So 1 minus x minus y should be greater than 0. So x plus y should be less than 1. The sample space is this. There is half. So it is at bottom is half. Upper is 1 by 32, 1 by 6. I just missed out the sample.
Okay,
Total sample.
that is correct. Uh, Say you have a non-negative random variable. Also, define what is a random variable first.
Random variable is a function x that is mapping of sample space to real line R such that
Okay,
uh, x is less than x belongs to the sigma field and skip sigma field.
so AI is the sigma field on omega. What have you written at the right? Belongs to what?
Skip sigma field.
And what is script A?
Skip is sigma field over the sample space.
Sigma field over the sample. Okay, that's correct. Uh, and can you define? Do you know what is a CDF? No, you know what's a CDF. What are the defining properties of a CDF?
CDF is non-decreasing. CDF, uh, CDF is non-decreasing. CDF is right continuous. F of minus infinity equals to 1. F of minus infinity equals to 0. F of infinity equals to 1.
Okay. So say you have a non-negative random variable. उसका distribution function is f,
Non-negative
right? Non-negative distribution function is f,
distribution function is n.
right? Now can you write the so this is a continuous random variable, okay? Can you write the expectation in terms of f?
This is a continuous and right? Its expression 1 minus infinity.
This is expectation of x. Okay.
Okay.
Can you prove this?
Yes. Expression is distribution x dx. Right. Now we can write x as 0 to x dy. And oh, it's non-negative, so it's looking right. X dx. So I can change the variables. Which y is less than x is less than infinity, less than 0, and if x dx, we can if x dx dy, we can change it and x y to infinity if x dx and dy. No, dy and y to infinity x will be is 1 minus x y dy. Right?
Good, Arnav. Yes, that's correct. Good. Do we have enough time? I think yes, we can do another question. Say x1, x2, x3 are IID uniform 01.
X1 is to X2 IIT uniform 0.
Right. Do you know what is mid-range?
What is
Mid-range.
mid-range? Mid-range. Uh, mid-range is no, I don't think so.
Do you know what is range?
Range is range is maximized model distance spectrum. Distance which is maximized.
Mod is not needed. Positive valued random variable. Okay. And so mid-range, I'll tell you what mid-range is. So mid-range is x order 1 plus x order 3 over 2. In this case, it would be x order 1 plus x order 3 over 2. Okay, this is mid-range. So can you calculate the joint distribution of mid-range and range?
Joint distribution of mid-range and range. Hmm. U is to and U is to x3 plus minus 2. Okay, so I do this just I find before this I distribution of ceramic just y minus x uh, square and one square one first minus minus one one.
Uh,
Did I explain in this video what are this joint
Arnab,
distribution of one thing? Did I try to?
You're not audible. Can you move the mic closer to your like, yeah.
I am telling. I think I just forget the choice distribution of Archie. In fact, by Harvard's perspective, as well as Harvard's
That is
perspective.
that is correct.
That is correct. Right? Yes. Okay. It is correct. So,
Your Jacobian was also correct, I think.
Jacobian. Yes.
Jacobian was correct. Acha, Arnab, we have to move to the statistics part as well. So you don't have to write the whole thing. Just tell me how would you proceed.
Yes.
Tell me the steps. You don't have to write everything because we have to move to the statistics part also.
Okay. Next, I will just uh, write this thing as a distribution. This point is equal to Jacobian. Right. Now, uh, U equals to range and P equals to the mid range. So
Hmm.
we write this in a way, we find x1 equals to something 2u minus b or something,
Okay.
x order 3 equals to 2u minus b or something like that. And we just put this distribution, right, function of u and function of and integer. And
Hmm.
the support is to that. Support is I I have in the video some equals to extra 3 minus 6 equals to I think the support is different from each other. I think the support is different. So this support will be you will be 0 to 1 and he will be also 0 to 1. And he will be 1, he also 0 to 1. Yes. I think so that is a support. Okay. Am I audible?
Hmm. I think it's correct. I think it's correct.
The board is small or I
No, I understand what you're trying to do. It's correct.
board is
Okay. Thank you, Arnab. That's it from my side. Now the
okay.
Shari will ask the statistics part.
Arnav, can you hear me?
Yes.
Okay. Can you define size, level, and powerful? You can write on the board as well.
Size and
Level, power. Start with size.
size. Uh, size is the bound that is set to type one. Can simultaneously decrease type one or type two rather
Can
rather
you write it in probability form on the board? You're not really audible to me. So,
sizes your type one and the form. Okay.
what is alpha?
Okay, I just got it wrong. Alpha is level of significance, right? And size will be the maximum value of type one.
Are you sure?
Power is the value of projective number. It is false. Alpha is level of significance.
Are you sure you defined size and level correctly?
I am missing out two different comparison is like we forget I read that size also is bound of that defines Level
Your
is power.
voice is cracking, Arnab. Just write on the board what is size, what is level, and what is power in a compact mathematical form. You wrote power correctly. Did you write H naught? What is that?
Inference.
That's size or power?
This is power. I told them size. I have got written size.
So this is power.
This is power. This
Okay.
Probability of type 1 error. Uh, maximum value of probability type 1 error is size, and we give a bound to type 1 in this test. The bound less than alpha. This alpha is level of the test.
So what is probability of type 1 error?
Probability of type 1 error is probability of rejecting null hypothesis given it's true.
Okay, does it have a name?
What probability is not by name.
See, Arnab, type 1 error is rejecting H naught when H
Okay.
naught is true. Okay. And
Okay.
probability of type 1 error is size. Size of the test is probability of
Probability.
rejecting H naught when H naught is true. And level is the supremum probability of type 1 error. So the alpha you're writing, alpha is the level, that is correct. But you wrote that maximum probability type 1 error is size, which is not true. It's the supremum of probability type 1 error, which is level. And size is always less than equal to alpha.
Oh, size is the size. Right.
That is, yes, that is size. So can you write down alpha now? What is the formula for level of the test?
The size less than equals to alpha.
What is alpha? You wrote something previously, you rubbed it out. There was a slight mistake in that.
So alpha is level.
Alpha is level. How do you, like you wrote size is probability of type 1 error. How do you write level? Probability, some maximum, minimum, something.
That is maximum.
Okay.
That is
Correct.
supremum.
Yes. Supremum over what?
Supremum over H1.
Supremum over theta belonging to the script. It's not.
H1. Yes.
And what is power?
Is equal to
Did you say H1 or H0?
H0.
Are you sure? Can you draw a power curve for me? Let's say we have a one-sided test, x1 up to xn follows normal mu comma 1 and under h0, write it down, I'm ready.
And then H0.
Mu equals 0 and under h1 mu is greater than 0. So can you draw the power curve for me? What should the power curve look like?
Should I calculate power first?
Yes. What is your test? You should define a test. What should be the ideal test to check for this hypothesis?
It's level up, right?
Let's say we have x1 only, just one sample point. What should be the ideal test?
Ideal test would be x1 and c.
Write it down. Correct. Now calculate the power.
If we see this working on higher possibility Yes.
What should be the power when mu equal to 0?
Sure. So when equals to 0 in 1 minus I of c.
So what is the power? What do you think should be the power when mu equal to 0? Is it something specific, something that you defined earlier?
Uh, it, it,
When
I
mu
need
equal to 0, it is h naught, right?
Hmm.
So what should it be?
I think the size of this AI to exact value c. Then I know exact value what the power of c. If I don't know c how, it is 1 minus capital phi of c. And the size of test to know this.
Okay, I could not hear anything you said. I am asking, let's say mu equal to 0. So what is the probability of rejecting h naught when mu equal to 0?
Uh, if n equals to 0, according to this, 1 minus capital phi of c. So 1 minus capital phi of c. Right, at when n equals to 0. And we don't know the exact value of c. To know this, I know the size of the test. Then I can evaluate the c. Then I find the exact value of c and c.
I think you're going wrong somewhere, but your voice is cracking, so I cannot comprehend what you're saying. Please check the definitions once again after this interview. Okay. Power, size, level, type 1 error, type 2 error. They tend to ask these type of questions. Okay. So check the definitions once. Maybe you're right, but your voice is cracking, so I couldn't understand. Okay. So what do you mean by minimal sufficiency? Can you formally define it? Minimal sufficient statistic.
Minimum sufficient statistic when statistic is sufficient and any other statistics needs to be sufficient, and any other statistic can be taken as a function of t. If there exists any other statistic that can be written as a function of t, then t is called minimum sufficient.
Any other statistic? Any other statistic?
That is not t. That is not.
You're saying that a minimal sufficient statistic is sufficient, which is correct. And any other statistic can be written as a function. So
Say that is not equals to t. Not equals to t itself.
do you mean any other sufficient statistic or any other just simple any statistic?
Any other sufficient.
You have to say that. Is there any way through which you can check if a statistic is sufficient? Let's take the normal example again. This time x1 up to xn follows IID, normal mu comma 1. And y1 up to yn follows IID, normal mu comma 1.
0,1.
If,
0,1.
if there is no parameter, how would you check for minimal sufficiency? Does not make any sense. Right, mu comma 1. Right, you've written it right. Okay, so can you check for, can you find out what the minimal sufficient statistic for mu is? First of all, what is the sufficient statistic for mu?
Sufficient statistic for me is this is how many times? N times, right?
N times, yes. Just take one sample. Just take for, let's say, x1 up to xn follows normal mu comma 1 IID.
Then,
what is the sufficient statistic for mu?
both are one sample, right? X1.
Just one. Don't take the y sample right now.
Okay. Then sufficient x1 plus x2. Sorry, x1 plus 5. x1 plus 5. 1.
Did you say something?
Yes. Say x1 plus y1.
Is sufficient for mu.
Yes.
I think this is correct when x1 and y1 are there, but I said you only have x1 up to xn follows IID, normal mu comma 1. So what would be the sufficient statistic? You don't have to write it. You know it. x1 up to xn follows IID, normal mu comma 1. Yes.
Oh, I properly.
Yes, right.
Then summation xi.
Summation xi. Okay. Okay. Yes, summation xi. Okay. So now can you tell me if I take another y curl following IID normal mu comma 1, how can you check for minimal sufficiency?
First I take xl, then take ys, right? Both are independent. Okay. Now it's combined sample sufficient that we need to find.
I'm asking how would you find the minimal sufficient statistic?
Oh, factorization theory.
Yes, that is correct. Do you know this, that if the likelihood, the ratio of the likelihood functions would be independent of theta if and only if tx equal to ty. Do you know this method of checking for minimal sufficiency?
Say this x1 equals to x1, xn equals to xn, given t equals to
No, I'm not saying that. Let's say that tx so
Am I audible?
yes, yes. Treat the two samples differently, okay? I think the y curl confused you. I was just trying to help you. I apologize on my part. So for x1 up to xn, the sufficient statistic is x summation xi.
Mhm.
So for y1 up to yn, how would you construct the sufficient statistic? Summation yn?
How to constant, right? I can use a factorization theorem. And this will be summation xi plus summation y.
I don't think you get my question, but it's already 4-3. So there is a method of checking for minimal sufficiency. Okay, you check the ratio of two likelihood functions or the two densities. So you can check that in Kessler-Borcher. How to check for minimal sufficiency? It's right there, I think, first or second page of minimal sufficiency. Okay, that's it.
Yes.
Yeah, are you done, this Hari?
Yes, yes.
And,
Okay. Yeah, Raghav.
yes.
Are you there, Raghav?